Hello again, my name is Andrej. I come from Fluxair Indoor Environment Solutions, and this is my second video of dry exhausting systems. So in the first video I described the parts, the elements, the basic operations of the system, so we're not going to go back to that. We're just going to focus on the difference between simple residential and this type of residential that has a few more elements in the system added to it. Those elements are, which are not part of simple residential systems, are, well, we'll start with the dryer outlet, so where the lint and the air is exhausting out of the dryer. So the first element is the lint trap. So if we're going from the dryer on, let's go in the direction of the airflow that's coming out of the dryer. The air hits the lint trap. It's a simple cube. It's got a cover on it and a metal screen. Metal screen is there. The purpose of a metal screen is to collect the lint and to protect the second element in the system, which comes after the lint trap, and that is booster fan. So the purpose of a booster fan is to increase the flow and increase the energy of the air coming out of the dryer when the system is too complex or too long. So the dry exhaust fan itself would have a hard time expelling all the air with the moisture and the lint itself. So it's an addition to add and facilitate the airflow of the dryer. These exhaust fans are located, well, it really depends on wherever it's feasible to place them, but usually they're not that far from the lint trap, and mostly they're installed in the ceiling with the access panels for maintenance and whatever needs to be done. We have them mounted sideways. But ceiling is the most common installation of these fans. We also have two different kinds of fans that are installed. I have the square box type of a fan. This is centrifugal fan, and this is inline fan. They both do the same thing, just there's a slight difference between the two types, and they have pros and cons when it comes to the performance, but usually this type, the centrifugal type, is a little bit more convenient simply because of the access. And we know that the air that's going through the system actually contains lint, and the lint does accumulate throughout the system on the sides of it, and also in the fan housing and the fan blades. And we really don't want to lint collected on the fan blades, because again, that reduces the performance of the fan. So maintenance is very important when it comes to dry exhaust systems, and this particular fan facilitates quite simple maintenance procedure when it comes to the fan itself. So as you can see, most of these fans, they have a couple of screws that come off very easily. Some of these are also hinged. So as you can see, the fan just lifts up. First of all, it provides access to the fan housing and also gives access to the pipe going towards the dryer and pipe going outside. So this is it's a very, very, very convenient place. So when we talk about the cleaning, this is the perfect location to access that. Plus, as you can see, the fan blades, they're also very accessible, easily to clean. But also, main thing, if you ever need to replace the fan, there's 4 screws in it. The fan comes out, the fan goes in, so the housing remains in place, does not need to be moved. So very convenient, very simple. On the other hand, when you have a booster, like inline booster fan, as you can see, it's fixed to the wall. It's got wiring and motor inside. So if you ever need to access it for cleaning, to access the fan blades, you have to remove the actual ducts that come in and out of the fan in order to get in. Plus, so the fan blades, they're tucked inside, they're very hard to reach in order to clean them, and not to mention if the fan breaks, so the whole housing, everything needs to come down and being dismantled. So that's why this is the preferred method of boosting the dry exhaust fan is a centrifugal fan. However, it's also important the type of fan blades. We also have a squirrel cage fan, which is quite okay for like general exhaust, washroom exhaust, and all the other exhausts that do not contain lint, and they just primarily exhaust the clean air with a lot of contaminants in it. However, with the lint, because it collects, it's a lot more susceptible to a blockage than this type. So this type of fan with this type of housing, and it's very easy, convenient. So this is the fan. Now we come from the dryer outlet, lint trap, ductwork, fan, and now the only thing that's left is to expel that air out of the fan through the wall vent. And again, this is another major difference between a simple residential and high-rise residential and also commercial wall vents. As you can see, this is the wall box that's installed during the construction. And the reason for it is that on high-rise buildings, once the outer cladding, whatever it is a brick or any type of cladding that's installed out on a building shell, it's simply impossible to get access after the fact. So when the system is installed, this part actually has to be completed. So that's why the wall box and the grill and everything is installed at the same time as the outer shell of the building. And so I'm gonna take it out. I'm gonna take out, so this is the typical wall box. So it connects to the duct on the outside, it goes in, and as you can see, there is a metal flap here. This one is fixed, but some are movable. And underneath, there is a rubberized fabric flap actually that's hanging down, closing the inlet or the outlet of the box, preventing the backflow. Okay, I'm gonna turn it the other way. So if you look at it from this side, so the air, it's going in through here. So you can see the cross bracing here. It's a metal cross bracing, and the purpose is to prevent the backdraft damper to be sucked in, to keep it in place on the outside. And as such, it creates, as you can see, it's right in the middle of the airstream, and it just likes to collect the lint. So again, all about the dry exhaust systems are all about the efficiency, so smooth airflow with no obstacles and nothing in the way. So this itself, this is the first obstacle created by the wall box. So now let's say that the air does hits the bracing, it goes through the hole, it lifts the backdraft damper, which opens and allows the air into the box. Okay, so the air comes into the box, and then it's coming out of the box through the grill. This is typical grill that's installed on a wall box. So unlike the simple residential vents, where the actual vent itself has a backdraft damper on it, and once it's open, the air has a clear path to exit the system. This is not the case with the wall box, because the backdraft damper is located inside the wall box. Now the air goes inside the box and it hits the grill, which has a fixed openings, and as you can see, it has to protect the box from pests from getting in, also the rainwater and snow, and so any weather. And this is what creates the major problem with the dryer. Why this type of exhaust wall box is not suitable for dryer exhaust fans. It works really well with all the other exhausts, but not with the dryer. Unfortunately, this is how it's done. And again, because of the way that the buildings are built, it's installed during the construction with no access to it, and that's what makes it incredibly difficult to maintain or clean these grills. So again, the lint is going blown by the air. Eventually it collects on the backside of the grill, and it's just a matter of time when this grill is gonna get plugged up completely by the lint. And now what to do then? So let's say that we're on a 20th floor on a high-rise building. Obviously, there is a way, but it's extremely difficult to access this grill from the outside of the building. So, and the inside, there's nothing. This goes in. This is all the wall box is part of the wall now. This is usually inside the drywall with no access to it. So it's just it's a Achilles heel of any dryer exhaust systems of this type. Getting access to this box in order to clean it, it's like I said, it's either through the outside or cutting in from the inside. So that means cutting into drywall, cutting into removing the pipe. So there's a lot of damage needs to be done if this box is to be accessed from the inside. And unfortunately, once this thing plugs up, and like I said, it's just a matter of time when it will be plugged up. That's quite often the only way to remove the lint and all the deposits that collect inside the box. So again, until they come up with a better solution or start putting a better vents for the dryer exhaust, this will just keep being like I said, the Achilles heel of it. Okay, so we went through all the elements of the system, and we learned what it consists of, and what are the weak spots of it too. So in terms of maintenance, it's very important that the lint trap screen is taken out and cleaned after every, probably the best if you do it after every load, but at least every second and third load, also depending on the accumulation of the lint on the screen itself. Usually the covers are clear, so you can see through it. It could be seen the amount of lint that's accumulated, so it should be no lint, because again, it will be obstacle preventing the dryer from venting properly, and going back to slowing down the drying process and increasing the time required to dry clothes. Moving on, the fan itself, if it's maintained and in a good condition, cleaned properly, the system should have no problem in running. Most of the time, these fans are wired in directly with the dryers, so it's as soon as the dryer comes on, the booster fan comes on automatically. Sometimes there are some setups when you have a separate switch for the booster fan, But anyway, it should absolutely run every time the dryer fan is running. The booster fan should be on. What are the problems and issues with the system? So of course, the first thing is the accumulation. If it gets plugged up with the lint, it's a common sense that tells you that it's going to reduce the amount of air going, and again, so the drying time will be increased. The clothes won't get dry in time, so the energy costs are going to be higher because the dryer is going to run longer. Plus, if it comes to the extreme situation, some of the element may overheat, and obviously there's always a chance of or danger of spark igniting the lint accumulated. So again, so the worst thing that can happen actually with the system is if the booster fan is not working. So now you have a fan which blades are stopped and the dryer is pushing out the lint. So the first obstacle that it hits is the lint trap. So let's talk about the effect of a lint trap here. So when everything is working fine, from this point on, when the dry exhaust, it pushes the air up to the lint trap, and then from this point on, from the lint trap outlet, it's actually the booster fan that's pulling more than the actual dryer vent is pushing. So I'd like to say that actually from this point on, the booster fan takes over in terms of energy transfer. So from this point on, so the dryer is pulling and pushing, obviously on the pressure side, it goes out through the wall box. Now, what's happening inside the lint trap? So as long as the booster fan is pulling, everything is working fine because the air that's been pulled by the booster fan is generally, and it should be, more powerful than the dry exhaust fan. So there's always more pull than push here, and that's how it should be. So let's say, for example, that the dryer breaks, so there's no pull here at all. So now we have a dryer that's trying to push the air with the lint through the entire system all by its own. So first obstacle is here. So the lint trap. Well, I don't have a screen on me, but so plus just the shape of the box itself creates a lot of resistance. Plus, if you add the screen in it, it only makes it worse. So I'm just gonna show you on a quick sketch here what basically happens inside the lint trap. So if there's no pull here, so the booster fan is off, so there's no pull, so all the air is being pushed by the dryer fan. So the air goes in the box, and some may assume that the air is going through this pipe. Once it enters the box, the air does not flow this way, just straight, and enters the pipe of the same diameter and just keeps moving. That's not what's happening inside the lint trap. So the air, as soon as it leaves this pipe, it expands, it goes wide like that. So the air movement is like that. As soon as it comes out of the lint trap inlet, it just goes like that, and then it starts hitting. So we have a huge, massive turbulence inside here, and then all that turbulent air, obviously there's a volume that's coming in, so it tries, and this is the only way out, so it will come out. But the energy loss inside this is tremendous, so it's going to slow down significantly the airflow, and by that reducing the overall energy, again affecting the dryer itself, because the air will not be moving as fast as it should. The dryer will taking longer, and obviously energy costs and drying time as well. So this is, like I said, if the booster fan is not running, this is a major obstacle. Okay, let's move on. So let's say that again, now we have a fan, whichever it is, either inline fan or a boost or a centrifugal fan. So this fan blades is inside, so the air goes in here, goes through the blades and out here. So again, so now the fan blades are stopped, so it's not moving. So now that's another obstacle. So the air has got to go through here. If in case the fan breaks down and it's still not jammed, it will slowly move the blades and it will turn. So that's also creating a lot of resistance, but at least some of it's moving. Worst case is if the fan seizes and there's no turning on a blade. So now you got a basically fixed obstacle, so the air hits that, and once it comes out of the actual fan housing, it's like it loses at least minimum 50% of the velocity and total energy from the point where it actually left the dryer. But that's not over yet. So now we're at the outlet of the fan and moving towards the wall box. And we said earlier what the wall box is. It's basically one huge obstacle as well. So all the air, it's lost all that energy at the very end, and on top of all that, it hits the wall box and the grill outside. So basically a system like that, it's probably running at 20 or 30, the most 30% of its performance from the optimum. So again, so this is the outcome and the problems if the booster fan in this type of system fails. Again, unlike the simple residential systems where there's no lane trap, no booster fan, it's just a straight pipe going out, there's not much that can happen in between except the disconnect and damage to the ductwork itself, but there's no elements that could break and cause a restriction. So that's why the booster fan is the most crucial element in this type of a system. Just to refer to some cases where I've seen people installing lane traps in the simple residential system. So we have a system with the dryer duct going up, lane trap, and then lane trap just going straight out. So I'm just going to go back to the same image. So that simple system with the lane trap is going to create this kind of turbulence, and again it will reduce its performance by 20% for absolutely no reason. Again, the lane trap, purpose of a lane trap is to protect the booster fan. If there's no booster fan in the system, lane trap doesn't do anything but create obstacle to the flow. This would be the outline of the residential, high-rise residential dryer exhaust systems. I hope I explained it, that I made it more or less clear and describing all the elements and its function. So I also hope that there will be more videos coming like that, maybe some other cases. Okay, so with this I will wrap up this video, this portion of the explanation of the dryer exhaust system for the high-rise. Again, high-rise townhouses, there's some detached houses as well that use this type of system with the booster fans. But again, the major thing is it's helping out the dryer fan to overcome all the resistance of the system if it's too long or too complex. Anyway, well, thank you for watching, and hope to see you on our next video.